Now it's
Okay,
fine.
thank you.
Thank you.
Thank you. I'm sorry. I will start over and we'll cut
Okay.
that. Great. Sorry about that. I will start over. Thank you for being here, everyone, and being patient. Okay, I will talk about proactive SaaS security from threats to actionable insights. But first, a little about me. So I'm Tal Peleg, and I work at Varonis as a security research team lead, and I specialize in infrastructure as a service, so things like Azure. What I'll talk about today is about threats to data in the cloud. I'll explain the shared responsibility model. Then I'll move on to present several vulnerabilities or techniques that we found in SaaS applications, including Salesforce, Okta, and Copilot, and more if we have the time. And I'll present takeaways for detecting and preventing vulnerabilities or these techniques from making a larger impact. And I'll present practical steps that we can take for securing data in end-to-end SharePoint. So a little about the shared responsibility. In an on-premises environment, we're in charge of everything from the hardware up to the software that's running on it. And then on top of that, data and compliance. So we're in charge of protecting our hardware, replacing disks. If there is a recall suddenly for servers, we need to make sure everything is up all the time. So moving on to an infrastructure as a service, in the most basic form, something like Azure, we would have, we can create, they provide us with hardware and virtualization, and we can create virtual machines, virtual networks. We still need to configure the network and configure operating systems, make sure they're updated. So in a serverless environment, if we're using serverless functions or a managed database, now the cloud provider is providing the operating system and the runtime environment, and we're just writing the software on top of that. But we might introduce packages, and we still need to keep those up to date. And the software that we're running, that we implemented inside of these, we need to make sure it has no vulnerabilities or security issues and address them when they're found. And on top of that, we still need to manage our data. And finally, when we move to using a SaaS application, the entire infrastructure is now in the hands of the SaaS provider. And but that doesn't, it shouldn't come instead of data security. So we still need to manage our data, right? Cloud vendors can't know what data we're storing, what our compliance needs are, and they won't be able to protect us from all the data risks. It's a shared responsibility. So who manages their data? Is it us or the SaaS provider? This is the main question, I think, that I still see companies might be having issues with. How do we secure data? There are so many applications out there. We need to understand what configurations we need to make in order to keep our data secure. And having so many applications that we're using makes this task very difficult for a team of security experts inside the company. And the third question, what is data security in the cloud even? So it's about controlling your data. I like to say, don't let your data control you, but control your data. For example, if there's a data leak, customers or law enforcement will come to you for answers. And if you don't know where your data is and how it moves from place to place, your data is controlling you. Now, data leaks usually start with misconfigurations or leaked credentials. They don't usually start with a vulnerability in the service where someone just accesses your data without you being able to detect or prevent it. And as we can see, in recent attacks, they targeted misconfigured buckets, public cloud storage, and the service provider can only recommend configuring the cloud environment correctly using security controls such as MFA. They say that the problem is on our side, the side that's configuring the service, and that we need to not accidentally make our data public. And moreover, if there is a leak, from in one of your cloud applications, it can affect the integrity of other applications as well. I was in a manager's course recently, and we talked there about circles of influence. So there are things that are inside of our control, and those things we need to manage and configure. And there are things outside of our control, such as zero-day vulnerabilities in cloud applications, attackers that are trying to infiltrate into our network and steal data, online scanners scanning our infrastructures, things like that. We can't control those. We know that they're going to happen, but we can monitor and protect from them, monitor and protect from these things and making an impact. And we do this by configuring things that we can control. So if it's an access policy, secure onboarding and offboarding steps, updating our data and software, encryption, things like that. What questions do we need to ask ourselves about our data? How do we implement these security practices? First, we want to control our data. And for that, we need to ask ourselves questions like, who can access my data? Where is this data? What is the data that's there and should it be there? What does protecting my data entail? How can the data be accessed? And what can someone do when they access my data? In order to answer these questions, we need visibility into cloud services, understanding how permissions work in each service, be able to monitor what activities are happening inside of our cloud environment, and maybe relations between different identities. We need to know the classification of our data and understand what normal and anomalous behaviors are. So to summarize this part, what is shared responsibility? Who manages our data? We do. How do we secure our data? Through concepts like least privileges and zero trust. And what is data security in the cloud? It's a shared responsibility. Now I'll present several vulnerabilities and techniques we found in SaaS applications, what we can learn from them, and how to practically implement some of these takeaways in Microsoft 365. The first example is a public link abuse that we found in Salesforce. So what I'll show here is a vulnerability in a third party, together with overexposed data, causes an increased impact. Then I'll talk about least privileges and monitoring access. So what is Salesforce? Salesforce is a CRM. And like a CRM, it has inside of it records, such as an account, leads, users, contracts, files that we're going to talk about, and relationships between them. Files in Salesforce are called content documents. And these content documents have inside of them a version and a body, or versions and their content. But apart from this, they have other records connected to them. So it could be the owner of the document, the parent directory, and any other resource, any other record that you want to connect to them. One of these records is a content distribution, which is actually like a configuration for the shared link preview application. So when you click on a shared link, you get either to see the file or to maybe enter a password. This configuration of whether the file is password protected, for example, will exist inside of the content distribution. And inside of this application, a colleague of mine, Nitai, and a good friend, found an SQL injection, which is actually the query language available in Salesforce. So this API, it's an undocumented API, but it was exposed publicly since the public link is a public endpoint. And what we could do is change the field that were retrieved for Salesforce records. And we could write a subquery. So a subquery such as this, we're asking for a field for a linked entity name, where the linked entity type is user. In SQL, this would look something like this. And since this API isn't able to parse subquery requests, if we if the query yielded any results, we would get an internal server error. And otherwise, if there weren't any results, the request would succeed with an empty list. So this allowed error-based enumeration. Using a query like this, we could help exfiltrate sensitive information about records related to the file, such as their name, phone numbers, addresses, emails, and so on. Before Salesforce fixed the issue, an attacker could exfiltrate sensitive data from other records, such as the document owner. So what can we take away from this? How do we minimize the impact? First of all, adhere to the list privileges principle. Don't provide users with more access than they need. Limit the creation of public links. If you don't need public links and you can share with specific people, that's better. But if you can't, use temporary access. Don't have a link to sensitive data or to any data shared forever if you don't need that. And review public access periodically to see when it can be revoked. Don't share redundant information. If you don't need data such as phone numbers to be inside of your CRM, but you want it to be in your directory, you can have it in your directory, but you don't need to automatically sync all the data from your directory into all the cloud applications that you're using. Because in that way, there are many more points of failure where your data can be exfiltrated from. And finally, of course, monitor anomalous access. So access to the undocumented API would be visible in Salesforce logs. You'd see a special shared link user reading records that it doesn't normally access, right? This user usually accesses content documents or files and doesn't usually access other documents that we'd be able to see in Salesforce logs if these were monitored correctly. So what can we do in SharePoint? Well, I want to show in SharePoint how to block creation of public links and enforce sharing with specific people. Another thing we can do is review and revoke unused access permissions periodically and review data shared with third parties and see when this data, if there's a third party that we're not using, for example, we can revoke its access to our environment. We can see which applications are using are high risk and using permissions that they don't require or excessive permissions. So let's see how I block creation of public links in SharePoint. First, we go to policies sharing. And in there, we can toggle external, we can move the slide bar and external sharing. Now we're allowing sharing only with guests, everyone in the organization, or specific people. Another thing we should make sure is that the default link sharing is set to specific people, only from people that the user specifies. And this will cause less people to accidentally create a link that's shared with the entire organization. Finally, we click on Save to save these settings. Are there any questions in the chat? Okay. So the next thing I'll talk about is Secret Agent. And Secret Agent is, well, many companies use the combination of Okta and Active Directory. And what we'll show here is how a compromised Active Directory, we can use these hybrid sync agents in order to access the identity provider and move laterally between on-premises and the cloud. So what is Okta? As I said before, Okta will allow, Okta is used to allow users in your company to single sign on into cloud applications that they're using. So how does this work? Well, in the first scenario, delegated authentication is enabled. Let's say there's a user, Bob, and Bob is trying to access Box. They try to log into Box, and Box redirects them to the cloud, to the identity provider, which is Okta in this case. Okta asks the Active Directory agent that's installed on premises whether this user can access Box. The Okta agent accepts the user's password and sends the reply back to Okta, and Okta redirects the user to Box. Now Bob can log in. Now, what if we had a secret agent? What if we compromised the Okta agent's credentials and were able to intercept its requests from Okta? Well, then this Okta agent would be able to send a login success message into Okta and log in as Bob without knowing their password. How would we detect this? Well, we could detect an inconsistency between the Active Directory and Okta authentication. So we could see that Bob successfully authenticated, but we wouldn't see a corresponding authentication request to the Okta agent, to the Active Directory, in the Active Directory logs. Now, if just-in-time provisioning is enabled, this would allow, this actually means that Okta redirects any authentication request into Okta to all the agents, all the Active Directories. This includes users that are Okta-only users, so users that don't exist on premises, which you may have a super administrative user or an Okta owner that you don't want to be an on-premises user. You want it to be an Okta-only user. These requests would also arrive at the agent. Another thing that would arrive are users that don't exist in Okta. So if when delegated authentication only, the user needs to exist and be mapped to the Active Directory inside of Okta. But with just-in-time provisioning, users can first time log in directly to Okta, and Okta will verify that they exist in the Active Directory and create a user for them inside of Okta. An attacker that compromised the Active Directory would be able to create a user to try to log in as a fake user, a user that doesn't even exist in the directory. And they could, in this example, the attacker is trying to log in with the name hacker, and it can set its role in the Active Directory as admin, hoping that in Okta, users that have this role in the Active Directory are also administrators in Okta, and by this way, escalate their privileges inside of the cloud. How would we detect this case? So we would see a fake user that logged in from a bad directory that maybe doesn't contain this user, and it was made an admin, which might be an inconsistency. Now, if delegated authentication is disabled, usually you'd have password synchronization enabled for the convenience of your employees so that they can use the same password to log into the cloud and to their personal computer and on-premises environments. In this case, an attacker could, if an attacker compromised the Okta agent sitting in the Active Directory, the attacker could cause the user to change their password, maybe by blocking the user trying to log in multiple times. The user will ask Okta to change the password, and Okta will forward the password to the Okta agent for the Okta agent to update it inside of the Active Directory. So with a compromised agent, the compromised agent would also receive this new password via SSL, but it would be able to read it. And in this way, the attacker would gain access to the password of the user. Now, how would this be detected? Well, when this happens, the user password is updated incorrectly inside of the Active Directory. Or you'd probably be able to detect something strange with a password update. So you could immediately request the user to change their password again and try to find out why this error occurred. Could also just be a bug. What takeaways can we take from this? Well, use multiple strong authentication methods. If Bob were to use MFA, this would block the attacker from being able to only use the Active Directory agent in order to access the user's cloud environment or cloud account. Employ security best practices at all levels, both inside of your Active Directory, inside of your network, inside your on-premises network, and in the cloud and all of your SaaS applications. Every single point of contact between these different integrations between cloud applications is a place where the cloud applications themselves don't have good visibility into and won't be able to do the best job in protecting you from threats. So this is something that we need as companies to be able to monitor automations and cross-account integrations. and use temporary credentials. So these compromised credentials of the Okta agent were long-lived credentials. They did expire, but only after, I think, 60 days. So using temporary credentials, short-lived credentials, will make leaked credentials much more difficult to utilize and abuse. What can we do in Microsoft 365? I'll talk about passwordless authentication, how to detect or hunt for lateral movement between on-premises and the cloud. So Microsoft provides many different authentication factors. Some of these are MFA strength factors, which work well as second factor. Some of them are passwordless or phishing resistant, which are also resistant to attacks such as MFA fatigue. Now I'll show how to create a conditional access policy enforcing authentication strength. So first, we can see in authentication strength, there are some built-in authentication strengths, such as this phishing resistant authentication factors. Apart from this, we can create our own authentication strength as well with factors that our company approves of. Now we'll go to Microsoft Entra Conditional Access and create a conditional access policy. You can either create a conditional access policy from scratch or using a template. We'll choose the require multi-factor authentication for admins template, just as an example. Now, this template will create a conditional access policy enforcing legacy MFA, which means it's just enforcing MFA, but not any specific factors. And we're going to go and find that policy and edit it to use authentication strength. So in grant controls, we can see that require multi-factor authentication is selected. We'll select require authentication strength instead. And we'll choose authentication strength that we want to use, which is phishing resistant MFA in this example. We'll click on select and finally click on save to create the conditional access policy. Well, what about threat hunting for lateral movement? So these use cases that we described in Okta are actually relevant for any hybrid environment. It can be also with Entra or with any compromised Active Directory agent that's synchronizing users between cloud and on-premises environments. So how would a new secret agent look? Well, this could be a new Entra Connect agent that we suddenly see active. Or it could be an agent that we recognize, but using an unknown IP, or letting unknown identities log into our cloud environment. What about the race condition in authenticating users with delegated authentication and just-in-time provisioning? Well, in this case, we could look in authentication logs. We can see a success in Entra, but a failure in Active Directory. See that a user was not supposed to be let into the cloud environment, but their login was approved by Entra. How would a new administrative user look if it's created by a compromised agent? So we would see a provisioning event inside of Entra, but it could have maybe an inconsistent group if it was added to the administrators group, for example. And it would suddenly have permissions that it doesn't have in the on-premises environment and that it shouldn't have in the cloud environment, as they weren't manually added to them or they weren't correctly added to them. What about the password leak? If there is no delegated authentication enabled, well, in that case, we would see the password rewritten in Entra, but not in the Active Directory, if it was the same example as in Okta. And otherwise, if a password is leaked for any other reason, it might be used anomalously, for example, from an anomalous country or in random hours, possible travel or things like that. I'll move on to Copilot. So what is blast radius exploitation with Copilot? Well, Copilot can index SharePoint sites and expose information to users in your Entra environment, like Nandeep and Smita mentioned in their presentation. And but what this means is that users are exposed to data, and now if it's a malicious actor that compromised the identity of a user or an insider threat, instead of what they needed to do before to access sensitive files, which is scan and download lots of documents, which would be easily detected. Now they can just ask the the AI agent, such as Copilot, to just return all the API keys, secrets, tokens, and user credentials they can find. And that agent, Copilot, would be able to return this information if it's accessible to the user, without the user even knowing what they're looking for. So the user doesn't even know that they're looking for a Redis connection password in this case. Even a user looking for something that they may have saved in one of their files, like connection details or the content details of a coworker, these Copilot might expose them to information that they're not supposed to access just because the data was shared with a company link or something like that. Copilot can expose data from any files that the user has access to. What can we do to reduce the blast radius? Well, first of all, we can detect dangerous or malicious prompts that might be exposing sensitive information. And another important thing is data segregation. Public data should be stored separately from sensitive data, and sensitive environments should be used from customers and environments where you want single sign-on, for example, and environments for employees where you want to store where you probably have sensitive data and internal company information. In this way, if you segregate these environments, and probably Rolf later today will talk all about multi-tenant and Microsoft 365, and it'll probably be relevant both for data segregation and data movement scenarios. So stay tuned for that. In this way, if you segregate, if you use a separate environment for guest users and for employees, guest users won't accidentally be exposed to secrets or sensitive documents. Another thing is use attribute-based access controls. So sensitivity labels inside of SharePoint, you can use sensitivity labels, and Copilot won't scan documents, won't even index documents that are classified as sensitive. And another thing, except for segregating your data, you should also segregate administrative privileges to reduce the blast radius of administrator accounts. So if an administrator suddenly clicks on a phishing link or something, they won't their credentials are compromised. If they use a separate account for administrative actions, they most likely will be connected to their normal account, and the user that compromised their identity won't have administrative access to the cloud environment. So how do we do segregation of duties in Entra? We'll show administrative accounts, how to move between a regular administrator account to a privileged account. And we'll talk about I'll talk about utilizing conditional access policies. So conditional access policies can be used also with sensitivity labels and authentication contexts to manage access to SharePoint, to sensitive files in SharePoint. And conditional access can be used in OneDrive Sync to allow synchronizing files from the cloud and onto personal computers only if these devices are domain joined, for example, are authorized. So how do we use administrator accounts? In this case, Nick Palmer is an admin, but they're using their regular account. They can list users or groups, as we can see here. So Nick is able to access and see the groups inside the directory. But now they want to create a conditional access policy. So they'll switch with just a click of a button into their administrative account. They'll create the conditional access policy. And once that's done, Nick will transition back to his regular user account so that his administrative access credentials are safe. Now, apart from this, we could also use privileged identity management and have Nick request permissions to use the administrative access role. And then what we get from this is that apart from just transitioning to their administrative account that will have the permission to request this access, another administrative user will also need to approve this access. And in this way, there is less chance that the administrative identity will be compromised by phishing. Are we on time? Okay. Oh, 15? Okay, thank you. Sorry. So I will talk about one more flaw, which is a SQL injection access flaw that we found in Zendesk. And Zendesk broke my personal record of the fastest fix from when I've presented this vulnerability. What we'll see here is the exploitation of a zero-day vulnerability added with self-service sign-up into a shared environment leads to data exfiltration. So Zendesk is also a CRM, and many times it's used as a help desk. And one of the products that Zendesk offers is Zendesk Explore, which lets you take analytics data from all other Zendesk products and present that inside of a dashboard. Now that dashboard has components called reports, which we'll talk about more. So why did we look at Zendesk Explore? Well, we started by looking at Zendesk GraphQL API. And we did this because GraphQL has relatively fewer hacking tools than REST APIs do. And for this reason, they probably have more vulnerabilities. We found some red flags for insecure APIs inside of Zendesk Explore API. We saw a complex API structure, nested encoding, redundant data that's sent in the API requests and responses. And it looks like a merge between a purchase startup and the main code base. So here's an example of nested encoding. We can see there's a JSON document with the XML inside of it and a JSON inside of that. We were able to use, so the API, one of these APIs is the API for previewing a report before it's created. And this API, actually, the front end would receive the schema of the table that it's querying, and then it would send that schema back to the backend so that the backend would know how to query the table. And that schema was not verified. So what we were able to do is change the name of a field in that schema, for example, and insert an SQL injection, SQL injection. And in that way we were able to compromise data. Now, this does require a user, but there was no access authorization check in place. No one verified that the user actually has permissions to create a report inside of Zendesk Explorer, and any user, even a guest user, was able to do this. So the attack flow works like this. Usually self-service signup is enabled so that users will be able to create support tickets or feature requests. A user would self-service sign up, create their own guest user, call the execute API, send a custom query schema because this was not verified by the backend, and in that way, use an SQL injection to leak sensitive data. So what have we seen today? We talked about shared responsibility. We talked about how least privileges, zero trust, and proactive threat hunting will help us not only protect our data from risks that we have today, but also minimize the impact if there is a zero-day vulnerability or another attack that does compromise our environment. Microsoft 365 techniques we talked about: disallowing public links, reviewing, revoking unused access permissions granted to users or to third-party applications, using phishing-resistant passwordless authentication methods, performing segregation of duties with separate accounts for administrative tasks, and proactive risk minimization and monitoring for threats and unused access. Now, just some final comments. Don't be overwhelmed. There are a lot of applications, a lot of security, but don't just shut down all sharing and everything, because this will, you need to help your employees and customers keep their data safe. So if employees need to share data with customers, but aren't able to due to your sharing policies, they'll find a way around it, and that way will probably not be monitored. You do want to monitor how your data gets from place to place. So you want to use secure controls, have secure controls in place, but not hinder the productivity of your employees. And finally, there are benefits to outsourcing cloud security. There are so many applications out there. You want to use security products and include SaaS applications inside your vulnerability disclosure programs. You don't want the first time you find out about sensitive data leaking from SaaS applications that you use to be when an attacker is asking for a ransomware to restore your data or to keep it hidden. Thank you. You can contact me by email if you have any questions or you want to consult about cloud security. Please contact me or any of my coworkers from Varonis who would be happy to help you. And you can also find me and some other vulnerabilities and details and best practices inside of our blog at Varonis, and be updated with the latest news in data security. That is this. And thank you, Drago, for organizing this conference, of course.